Today on NerdOut, DripDropz Remote Signer. Welcome back to NerdOut, the show where we take a look at Cardano and we break it down, but we don't dumb it down. Today we're talking about the DripDropz Remote Signer tool. So let's take a deep dive into it. So what is Remote Signer? It is an open source tool put out by DripDropz. You can view it at this URL here. The main purpose of it is to shift custody away from DripDropz. DripDropz is in the United States, and as we know, that they're not the best for crypto when it comes to regulation, but it shifts the custody as DripDropz owning a given token or ADA in a secure manner. It uses a gRPC streaming API to communicate with it. And I wanted to present it here today just to show that this technique or way of communicating could be reused by other projects or anyone who needs alternatives to taking custody of the assets in order to help a customer do something with them. So it's a way to let the customer maintain custody of their assets without taking custody yourself to help them. So how does it work? At the top level, there's a TLS secured channel. This is the same as when you go to an HTTPS website. So that's kind of the top layer of security. So it privatizes the whole connection. Below that, there's a JWT authentication piece. So the remote signer needs to have a pre-shared key that was given to it by the DripDropz server in order to even make the connection. So it won't even allow it to connect if you don't have this JWT key passed along the secure channel. The layer of security below that is a handshake and a response transaction that happens. And we'll go into detail about how that works and how that secures the channel. But the main thing is you don't want the remote signer signing any transactions that it hasn't specifically authorized ahead of time. So, you know, this technology, if the remote signer connects to a server that it thinks is DripDropz, and then it's telling it to sign transactions, that could be really bad. So we have to really make sure that the remote server that it's communicating with is the one, in fact, that it trusts. After that handshake and response is successful, then we have transaction requests that come to this remote signer for the key it controls. It goes ahead and signs those transactions and sends the signatures back. So this technique, as you can imagine, could be used for any number of things. It could be used for, you know, multi-sigs. It could be used for any number of things where you want to specifically trust some other entity with your key for a specific period of time. So the remote signer is in control of this process the whole time. They can shut it down. They can do anything at any time to turn off any ability to sign transactions. At the same time, this handshake allows DripDropz to trust that this remote signer actually has control of the key that it says it has control of. And then finally, there's ping pong responses to keep the tunnel open between these two. It's a streaming API over gRPC. And then also it's a liveness check. So it makes sure that the remote signer every so often, every so many seconds, is alive, and it says, yes, I'm alive and still available to sign transactions if you need me to. So let's talk about the details of it. It's a command line tool, and it's also very containerizable. It has the parameters can be set on the command line, or they can be set via environment variables. So if you have, you know, a secure key storage on AWS, or if you're running this potentially, we've been talking to the Santiago down at Demeter.run. This could be something that could run there if we have a client that needs this type of solution. It could run there. So this a little bit of background. This whole thing came about because we were talking with one potential client. The deal never went through, but we decided to build the tech anyway. But basically, they wanted the ability to drop ADA through DripDropz, and that's kind of a non-starter. You know, that's very much something we would need a full-blown money transmitter license for, that costs anywhere from 250 K a year to maintain those licenses to, the initial purchasing or going through the process to get those licenses in all 50 states is astronomically expensive. So this is something we looked at doing so that they could keep custody and we would still be able to potentially drop those ADA rewards. But anyway, we went ahead and built it out because it's good tech anyway, and open sourced it as well. But yeah, it could be containerizable if you have a secure storage vault and then you launch a container in a secure environment specifying all of these environment variables with values coming out of the vault. It's a pretty robust environment. But basically, yeah, you're going to need to know the host, in this case DripDropz. But again, there's nothing that says that another service couldn't implement the server-side piece of it. It doesn't have to be DripDropz. The port that it communicates on, the host public key, this is shared, pre-shared. So this is the master key that proves that, yes, that server is who you think they are. The address, so that's the address that you're going to sign for. And your private key, your public key for that address, and then also the JWT token, which is pre-shared, of course. So that really ensures that you know who you're talking to. So let's talk a little bit more detail about how the handshake process works. So step one is the remote signer starts this whole process. The server, doesn't have anything to do with it. So the remote signer is in control all the time. And it generates a challenge string. So it always starts with remote signer _, and that challenge string ensures that we never accidentally sign something like a real transaction. So a real transaction will never start with remote signer because obviously that's not valid CBOR, so it's not going to sign anything that could end up being a real transaction. So what it does is it generates this challenge, and then it's going to sign the challenge itself to authenticate itself with the server. So to do that, it takes this string, it hashes it, and then it signs it with the private key, so it proves that it has ownership of the private key. Then it sends this challenge string and the signature and the public key that it owns to the server. And then the server can then verify, in this case it's DripDropz, the server can verify based on that public key and knowing the challenge. So the server goes through its own hashing process, takes that challenge, hashes it, and then verifies that signature and public key. So at that point, it knows that the remote signer client has control of the private key for that address. So I forgot to put it in here, but the address is also sent, and that is something the server also checks. It takes that public key and runs the hash on it and makes sure that it does relate to that address. So it is assigned to that particular address. After the server has verified the client, the server then has to verify itself to the client. So the server goes through and hashes and signs the challenge with that private master key, verifying that there's no man in the middle. So, and then it sends its signature back to the remote signer, which already had the pre-shared public key of DripDropz, knows that there's no man in the middle at that point because it's verified the signature. Okay, so that I guess was step 6. The server sends the signature back to the remote signer, and at that point it adds it to a list of signable keys that it knows that it can ask the remote signer to sign things. So if any transaction comes through that says, oh, this transaction needs to be signed by this remote key, it can then communicate over this tunnel to say, here's a transaction, I need you to sign it. And the remote signer can then look at the transaction and give a signature for it because there's a trust relationship built at this point between the two, and it's uber secure. So then the final step is that remote signer verifies the server signature, and at that point it knows that it's talking to the right server, and so it'll start responding to pings and pongs at that point, and if there's ever a transaction that comes through that it needs to be signed by its key, it'll go ahead and sign that. And that is how the remote signer at DripDropz works. So again, check the link in the description for the link to the GitHub repository. Feel free to take a look at it. This is all built in Rust, so it's uber secure, it's uber fast at signing, and it uses kind of a minimal set of additional Rust libraries. So it kind of does one thing and does it very well. That's kind of the whole idea with it. So with that, nerd out.